development. I will be walking through this topic for the next 40, 50 minutes or so, and hope you gather some useful insights into what context engineering is. But before we begin, I'll give you a little background on myself. So as the doctor said, my name is John Sukup. I am CEO and founder of ExpectedX. I've been working in data, AI, ML for almost 20 years now, which is hard to believe. Started off in consumer market research, worked for Levi Strauss & Company, which many of you are probably familiar with. Also worked for Cisco Systems as a professional trainer, Ipsos, and Anaconda. So my experience is pretty varied. I've worked in a lot of different roles over the years. My background in MLOps, agentic AI development, AI ML pipeline solution design, consulting, professional training development, pretty much everything from very low level roles all the way up to leadership and more strategic positions. Also the co-host of the Unriveted podcast, which is available on YouTube and other podcast distribution networks, where we discuss AI, digital transformation, and people. And finally, I am also the co-author of AI in a Weekend, an Executive's Guide, and the upcoming textbook release, if anyone still uses textbooks, that is, for Scikit-Learn Cookbook 3rd edition, which I believe would be released next year. All right, so to start things off, I want to kind of present everyone with a question. So what if programming really meant orchestrating information systems rather than writing individual lines of code? So the current landscape right now is estimated about 41% of all code is now AI generated, and 76% of all developers are using AI tools in some capacity. So we can think about this in the perspective of context engineering. So context engineering, what we'll be talking about moving forward, really represents a fundamental shift from crafting clever prompts to architecting comprehensive information ecosystems for AI-driven development. So the key takeaway that I want to have here, and I'll have some more at the end of the presentation, is really understanding what the architectural principles are that will define the next decade or so of software development. I want to say that very loosely because, as we've all seen with AI, things change very quickly. So if you ask me the same question in a year, we might be talking about something completely different. Also want to bring the point that this is not going to be a technical demo. I'm not going to walk through code or demonstrate any actual code use cases with context engineering. If you are interested in that, I do encourage you to contact me after the presentation, and we can collaborate that way. I'll be sharing my contact information. All right, so what exactly is context engineering? So the formal definition is context engineering is a discipline of designing dynamic systems that provide the right information and tools in the right format at the right time to give an LLM everything it needs to accomplish a task. So this is really an evolution from the first kind of use case of using LLMs for code generation or software development. Those are very much based on kind of this single turn approach where you wrote a single prompt, you got a single response, and then kind of a conversation back and forth. Context engineering is more focused on kind of a system level architecture. How can we think about building software using natural language in a more holistic, all-around approach that kind of goes back and forth? Thinking about that, this brings to mind the topic of what we call the context pyramid. So this is how we go from foundational knowledge to some sort of integration layer to real-time interaction. So breaking down each one of those concepts. We can think about the foundational layer as kind of the static domain knowledge that our AI tools need to have in order to perform a particular task. So that could be information within the documentation of our business. That could be information in the documentation around the tools that we're going to use in our tech stack. The integration layer is in how do we create tools so that our AI agents can access that information in a way that allows them to utilize it during the software development process. So this is things like retrieval augmented generation systems, model context protocol, MCP systems, or other ways to access even basic APIs. And then finally, the real-time interaction piece is how we interact with the LLM agent itself in real time. How do we write prompts? How do we manage our conversation history? And how do we manage the immediate instructions that we give to our LLMs? So you can think about this in the example of, say, you build a chatbot for maybe a legal, a law firm. The foundational knowledge would be things like information on laws, within your city or your state or your country. The integration layer would be, what do we build on top of that in order to allow our AI access to those systems. So again, that would be like MCP tools or APIs. And then finally, the real-time interaction is, how do we craft prompts like what legislature recently changed in terms of real estate within my particular region, and how that information is then extracted from those foundational resources and utilized for whatever our use case is. So the core components of the framework, context retrieval and generation. So as I mentioned, retrieval augmented generation systems, semantic search and knowledge graphs. There's also context processing, so compression, ranking, formatting, and optimal model consumption. These topics become very important, especially when we consider using context engineering at an enterprise level, where we're making several calls to LLM agents, and how the number of tokens that we're sending and the number of calls that we're sending, the number of API calls that tools are making. As you can imagine, that adds up and becomes very costly over time. We'll talk about that in a little bit in some of the next slides coming up. There's context management, which is also very important, which is the memory systems that we provide to our system in a context engineering environment in order for it to remember things that happened in the past. And this can be updates that we made to our code, or even more high-level elements of our overall software engineering project. And then finally, 4 strategies that we'll talk about later in the best practices section: the write, select, compress, and isolate prompt. And we'll talk about those a little bit more in depth coming up here shortly. All right, so how does context engineering differ from traditional programming? So this is one of those topics that I think a lot of people, they get kind of frightened when we talk about artificial intelligence, taking our jobs or making our jobs obsolete. There's two sides: the people that say that will never happen, we'll just make more jobs, or then you have the people that say, we're going to be sitting around doing nothing all day because robots are doing everything. I don't know which one of those particularly I would prefer. As long as I can still, pay for my lunch and dinner, I guess I wouldn't mind not having to work as much. Anyway, traditional programming isn't going away. It's really becoming kind of the foundation on which context engineering operates. So traditional code really still handles the critical infrastructure in software developed using context engineering. So databases, API connections, security layers, network protocols, these will all still be managed by traditional programming approaches. These systems still require deterministic programming. We can't really rely on AI to creatively interpret how to handle a financial transaction or commit to a version control repo. And traditional programming still gives us reliability and performance guarantees that context engineering layers can then be built upon. So context engineering is about the choreography of information flow to guide AI agents towards useful outcomes. So instead of necessarily writing explicit instructions, we're designing information or informational environments for AI agents to work within. So you can think about this, hopefully this is a good example, between the difference of programming a robot, every movement versus training, say, a service animal to do a particular task. So the robot follows commands, very much in order, whereas a service animal is going to, learn and understand the context of a situation and not necessarily adapt to a very stringent set of steps. And finally, the future, again, isn't one or the other. It's not going to be traditional programming or context engineering. It's going to be an intelligent combination of both of those. So the deterministic components in traditional programming will give us things like this function will return a sorted array. The probabilistic components that we get from context engineering say this AI might suggest, for example, a better sorting algorithm based on our data pattern. So the real art and the real skill that I perceive that software and context engineering software developers are going to need in the upcoming years will be to understand the art of when to know the traditional approach versus when to use the more creative approach that we find in context engineering and how to differentiate between those two. All right, so let's look more closely at the elements that make up context engineering in my context engineering pyramid, which actually looks more like a haystack, so don't laugh at my inability to create graphics. So what is the foundational element? And again, you may also, based on your experience, feel like there should be a different ordering of these, so this is my opinion based on my experience. I'm definitely open to hearing what your opinions are. But I think the foundational element of building using context engineering is the memory. So we have short-term memory, so understanding the conversation history and our interactions with our LLM coding agents. We have long-term memory, so what are the conventions that we set up within our software engineering project? Architectural decisions as well. Then you also have things like semantic memory, so what kind of facts and preferences and learned patterns do our agents learn over time? And then you have procedural memory, so these are like workflows, standardized processes, and how those should be carried out in order. So memory persistence strategies and optimization, I think, is really a key element for building these types of systems correctly. Next, we have product requirements documents. This would be PRDs in the context of context engineering. So these documents are kind of like the most basic yet most important document that we should include in our project when building with a context engineering focus. So these documents are things that contain the problem we're trying to work on, the solution we're trying to develop, goals of the project, types of users of the project, resources, tech stack, product, workflows and features. So how do we think about our entire project in terms of a natural language representation? We were writing a book on describing our software that we want to create. What would we write down? And I think that getting this right, now it's an evolution over time, and you're always going to have changes as the process goes along. But getting your PRD document as close as you can to your idealized version of what you want your software to look like as quickly as possible, from my experience, is a very important thing to do, because when it comes to refactoring code bases or changing out elements in your tech stack after they've already been implemented in your code base. AI agents are not very good at that, or they make lots of mistakes. The next element is slash commands or explicit control commands. Now, the term slash commands is very specific to Claude Code, so if you're a Claude Code user, you're probably familiar with this. I'm not certain if some of the other tools have the equivalent of slash commands, but I would be surprised if they don't. So slash commands are like little small functions that we can include within our context engineering AI agents in natural language still that perform specific functions. So these are kind of like built-in customizations that we can use in our workflow. And the good thing about slash commands is that they can often be chained together to create complex operations, which leads to the next element, custom workflows and control flow. So we can think of a series of slash commands. So think about if you're trying to make a commit to your GitHub repo. You might first add modified files to the commit, write the commit message, and then push the commit to the remote branch of my project repository. So you can think of each of those three steps as potential slash commands. They all are very small elements, but when combined together, they can become my GitHub version control workflow. Now, this isn't to say that all workflows are created by joining together slash commands, but you get the idea. Workflows also allow for human-in-the-loop approval patterns. So rather than just letting our AI agents create code off on their own and not paying attention, which sounds ideal, let's go and have lunch and let my coding agent do the work for me. You definitely don't want to do that nowadays, as agents are not that powerful yet. And workflows also allow for checkpoints, because agents in context engineering systems sometimes tend to overwrite code that was working or delete. We'll talk a little bit more about that. So having the ability to roll back changes is very important. MCP servers and tools. So again, we talked about model context protocol servers earlier. So model context protocol is a AI agent, big industry standard now. So pretty much every single foundational model or system that uses LLMs as a backing tool will incorporate model context protocol. So basically, an MCP server is a layer of abstraction between our LLM agent and some third-party service. So that could be like a database service like Sukup, a deployment service like Vercel and Cloudflare, and it basically allows our agent to interact with those services in a highly defined manner that doesn't require us to kind of reconfigure that agent every single time we want to interact with that. And even all the better if that third-party tool has APIs associated with it. So essentially it gives our agents the ability to utilize tools, knowledge, and systems far beyond what we may have given it at the beginning in order to complete its task or goals. And then finally at the top we have agents or multi-agent systems. So agents are what's actually performing the actions within our context engineering environment. So agents are really just composed of hyper-isolated and focused LLMs that are designed to perform a specific type of task. There's different patterns we can organize our agents in. We can have an orchestration agent that distributes tasks out to different agents within the ecosystem and basically combines all the inputs together to a final input. Or we can have agents that act in a more autonomous fashion and can communicate with one another as they see fit. There's a lot of different tools out there. If you were at the presentation last night from the user group, we talked about the agent development kit, which is another paradigm that the doctor walked us through last evening. So this is basically the general composition of a context engineering system and the components that are involved in that system. So I've been mentioning Claude Code quite a bit, and that's just because that's system of choice, tool of choice that I use within my organization. Not saying it's the best, and it has had some issues recently that have been resolved, but there are many other tools out there. So for orchestration, it includes slash commands, workflows, and the general orchestration document, which is called Claude.md, a markdown file, again, all in natural language. Able to utilize MCP servers, CLIs. It's natively able to access the GitHub API and has support for different IDEs. I use VS Code. And you can build isolated agents specifically for different tasks within your Claude Code distribution. There's other tools out there that you can use for context engineering, so GitHub Copilot, Cursor, Gemini Code Assist, Windsurf, Replit, Lovable, all in differing capacities, but just wanted to bring this to your attention. Claude Code isn't the only tool out there. Excuse me. All right, so let's talk about context windows. So 2 years ago, not that long ago, we would have celebrated LLMs that could have ingested as input 8,000 tokens. Today we're working with models that can process entire code bases, books, documentation sets, all in a single context. So when you think about writing a prompt in an LLM, you can think about the size of that prompt as the context window, right? So the larger your prompt is, the larger your context window is, and as you have conversations back and forth with your LLM, that context window gets smaller and smaller and smaller because it can only hold so much in its memory. So the size of the context window is typically seen as the bigger the better, but we'll see that that's not always the case. So some models that exist have 128K tokens for their context windows, GPT-4o, Mistral too large. Then when we get a little bit larger, 200K token context window. So Anthropic's Opus 4, Sonnet 3.7. Then we have some of the larger LLM context windows like Claude Sonnet 4, Gemini 2.5, which have context windows of 1 million tokens. And then we have Meta's Llama 4 Scout. I have not used this one, I've only heard of it a few times, but it apparently has a 10 million token context window. And I believe there's even an LLM out there that has a 100 million context window, although I don't know if anyone's actually seen that one work, so it could just be, you know, someone's brilliant idea that doesn't actually exist yet. But anyway, when we think about, you know, does a larger context window necessarily mean that the model is going to be able to perform better in a context engineering environment? So there's a couple of considerations. So one is called the loss in the middle phenomena. And this basically says that if you type a prompt of, say, you know, let's say 10,000 words into a given model, and however that translates into tokens depends on the model. But say you have a very, very large prompt that you put into an LLM. So the loss in the middle phenomenon says that models tend to perform better on information that is either at the very beginning of that prompt or at the very, very end of that prompt, and that the information in the middle often gets lost in model context memory. Another consideration is called attention dilution. So the more context that you provide in LLM, sometimes, you know, it's like if, hopefully the slides of my presentation are somewhat engaging, but if I gave you a presentation that was just, you know, 10,000 words on the screen, you know, your eyes would probably cross or you quit the presentation. So So this is necessary to say that if I were to inundate you with context, that isn't always better. So LLMs, very similar to humans, are not going to be able to handle context if you throw so much at it sometimes. So a practical tip that I'll offer on this is that critical information, especially in terms of the loss of the middle context that I mentioned earlier, critical information should either be positioned at the beginning or the end of the context window. In the second part, or attention dilution, make sure that every element of your prompt within what you're sharing with an LLM is meaningful. I can't remember the statistic, but I think it was Sam Altman from OpenAI that said, you know, they process like 10 billion tokens a day of people writing thank you to ChatGPT, when obviously, you know, that's not really making much of a difference. So they're processing all these thank yous to an LLM that's basically unneeded text. All right, so what are the pros and cons of context engineering? I think we've talked a little bit about some of these here and there up to this point. So advantages, productivity acceleration. So it's estimated that 92% of developers have adopted, or 92% of developers speak of there being genuine value in using context engineering with AI code agents. This means you can do rapid prototyping, eliminating the need to write boilerplate code, so that's all automated, and enhanced code completion with context awareness, like you see in GitHub Copilot. It's also allowed for innovation enablement. So instead of focusing on, you know, did I put a period or a comma in the right place in my code, we can think more about the high-level architecture of what we're building. It's given us faster iteration cycles, again, so we can experiment, see what works, what doesn't work, for adding features or you know, just doing things that generally improve the business that we're trying to build around our software. And it's reduced the barrier of adoption for new developers, right? So new developers can already hit the ground running without having to worry about learning every single element within the code base that we're working on. Now, what are the cons? So there's security vulnerabilities. So it's been estimated that 45% of all AI-generated code contains some sort of vulnerabilities. Again, I've been throwing out a lot of statistics in this presentation. I promise you they all came from sources. I'm not citing all those sources in the presentation, but if you are interested in any of these sources, you can contact me with my information at the end, and I will send those your way. So with these novel AI-specific risks, we have package hallucinations, so references in our code to dependencies that don't exist, or vice versa. We might have dependencies that are, you know, unneeded that exist within our code. Training data that can be poisoned, either on purpose or accidentally, that might make our AI agents write, you know, back, you know, security holes within our code without us even knowing it. There's been real-world incidents. So Samsung employees on 3 separate occasions fed ChatGPT sensitive code and intellectual property, which now resides basically in the brain of ChatGPT. Other elements, tech debt and code quality. So we have the multiplication effect. So some estimates say that there's been an 8-fold increase in code duplication since we started using AI agents for building our software. There's also what we call the infinite maintenance problem, because our code bases start to become very, very bloated with code that we might not use anymore, or code that we started using and then we change direction. There are ways around this. Obviously, you can create tools or even slash commands for identifying these temporary or test files within the database and putting them in fashion. And then there's the long-term sustainability crisis, which says that, you know, model deprecation risks leaving unmaintainable code, right? Or if we, for whatever reason, stop having access to whatever LLM wrote our code, we might not be able to figure out how it works if we can't access that model again. This also means that knowledge transfer between software developers could potentially be at risk. And then finally, you have operational risks. So there's been nightmares of code reliability. So one example is Replit. Most of you have probably heard of Replit. But this year they had a database deletion incident where over 1,200 companies were lost out of their database and 4,000 or so fake records were created. Google Gemini also had instances where its CLI tool was just destroying projects on its own, and incidents with Cursor where it was overwriting human-written code without giving really an explanation as to why. And then finally, quality control challenges. So again, this is kind of with the long-term sustainability crisis. Opaque decision-making. We don't know why our LLMs are making code the way they're doing it. There's issues with developers, especially senior developers, trusting if AI code is reliable. And then 75% of those using these tools don't even have training in software security, so they wouldn't even really know what to look for if they were looking for software vulnerabilities. Obviously problematic. So some optimal context engineering strategies and future directions. So LangChain, which is a developer for building AI agents, it's an open source framework. Again, I think the doctor talked about that in the presentation last night in terms of LangChain and LangGraph. But their approach for the optimal context engineering strategy is in these three parts. So there's the writing context. So writing context means saving your content, saving what you're doing outside of the context window to help an agent perform a task. So this means creating like markdown files or text files that you can store as documents within your code base that are not directly in the context window of your LLM, but can be referred to in the future when needed on the fly, which significantly reduces the number of times you have to make calls to outside tools. And then the selecting was the intelligent retrieval of relevant content. So again, this is aligned with the right paradigm, is how do we teach our LLMs in the context engineering strategy where to look for particular information. This is, again, makes it easier for our models to not have to reach out and make calls to our LLM models every single time and try to figure everything out from the beginning when we already have that information saved in documents. The compress element, which says as our context window becomes bigger, once we reach that maximum size of our context window, once you reach that 1 million token range, our LLM is going to say, I can't take anymore. We have to do something with our conversation in order for us to continue with a new context window. So compression is how do we take and summarize that conversation into a much smaller summarization that we can refer to and continue our conversation on in the future. And then finally, isolation. So how do we, isolating context really involves splitting our tasks up into much more smaller, digestible elements that our agent can work over. So if we try to write a giant prompt and tell our agent to do 5 different things all in the same prompt, it might do the first 2, I might think it's done the last 3, and I might even tell you it's done the last 3. And I know this from experience as well, is that creating very small, manageable tasks within context engineering paradigm makes it much easier for our agents to achieve what we want them to achieve and to not create errors in their judgment or in the code that they write. I've got a couple of other points up here. I'm going to skip over these just for the sake of time, but I think we'll probably make this presentation again, contact me and I'll let you know if you have any questions on these. We also have the recommended learning path about what I would suggest you focus on if you're trying to build out a understanding and skill set in context engineering. All right, so time for my shameless plug. So context engineering at Expected X, my organization, rapid prototypes, real results. So we've been using context engineering for a while now. I will say it is not a completely foolproof approach to what we're doing or what any company's doing. It will not write code for you while you sleep, while you go and have lunch. And if you do, it will most likely leave errors here and there. So the way that we use context engineering is we have created a customized Claude Code development environment for validating startup ideas prior to larger investment in developing products, as well as developing MVPs. It's composed of 12 agents for front-end services, back-end authorization, testing, databases, SEO optimization. We even have a payment agent that is designed specifically for implementing Stripe within a landing page. So these automated services are all linked together using a slash command. So there's a slash command right there if you're wondering what they look like. So we created one called requirement start validation that uses validation as a flag. Basically walks a user through an interview of 20 questions and then uses the information from those 20 questions to automatically generate a series of landing pages to test different copy and prices. Think of it like A/B testing, only this is like A, B, C, D, E, F testing. For their startup that can be deployed automatically or at least close to automatically within a couple of hours rather than a couple of days or even weeks. Our tech stack, VS Code, we use Next.js, Python for any AI ML backend, Supabase for database, Resend email management, PostHog for Google Analytics, Clerk for authentication, Stripe for payment, and Vercel for deployment. All right, so key takeaways as we start to wrap things up here. So number one, context engineering transcends simple prompting. So it's really about architecting information systems. Like I said at the beginning, it's about thinking about your software development project like it was already completed. What does it look like on the outside? How does it function on the inside? How do different services interact? Capturing all that within your product requirements document is key to kicking off your context engineering AI-assisted coding project. The current tools show immense promise, but again, there are definite risks. I've walked you through those. So again, don't think that you can just hit the button and let your AI agents create your next $1 million app. It's probably not going to happen. And if it does, congratulations, I guess. Next, the window for establishing governance framework is narrow but critical. So this is in terms of, how do we standardize best practices across tools that are released? Is that even something that we can do? If we want to have more organizations adopt using context engineering along with AI-assisted code generation, we need to have safeguards in place that will alleviate fears from these individuals so that they are more likely to implement these types of tools. And then finally, success requires hybrid approaches. So maintaining human judgment is still going to be very important at this point. It's very unwise to create a project using context engineering and AI agent and deploy it without having someone, at least today, again, ask me in a year, maybe I'll tell you something different, look over what has been created. All right, so a final thought before we close out here. So with 95% of code projected to be AI generated by 2030, competitive advantage won't come from avoiding these tools, but by mastering their orchestration through sophisticated context engineering. So the question isn't whether to adopt these approaches, but how to do so intelligently, securely, and sustainably. All right, so let that sink in. And I would like to thank everyone for joining me tonight, or wherever you happen to be in the world. There is my email address, john@expectedx.com. Visit my website, expectedx.com. And every single one of you, I hope, will connect with me on LinkedIn. There's my address. If you can't find the address, just type my name in, and I'm the one. That creepy picture you just saw of me zooming in on my eye, that's actually my headshot on LinkedIn, so I'm sure you'll be able to find me. But thank you very much. Hopefully you learned something, and I wish you all the best in moving forward on your context engineering journey. So thank you, everyone.
Thanks, John. I think there are some questions. I think you still have some then before you go.
Yeah. I have a couple minutes, maybe for some.
Yep.
Okay, so what are the current capabilities and limitations of AI in helping design and implement complex architectures, such as SOA or microservices? So, I mean, I think regardless of what you're trying to architect, as complexity increases, it's already going to be a burden on any AI tool, regardless if you're using context engineering or just simple one-off prompting. I think that some of the tools you're seeing right now that are working much better for AI stability are things like V0, which isn't really a microservice, or I mean, it might not fall into that category. But when it comes to like very specific applications, I think that these tools are going to fail. I think that it works best on tools that or applications that have already been done many times, and there's many examples. It's just like a machine learning problem. If you have more examples, in this context, more code, then you're going to be able to train that LLM to do those tasks more easily than if you have some very one-off case that you might not have a lot of examples. So hopefully that makes sense. It looks like it did. Very important, if an AI eventually replaces most junior developer roles, how will you ensure there's a pipeline for training future senior developers? That is also a very good question. I don't have an answer to that, but I will say that I myself am not a traditionally educated software developer. I didn't go to school for software development. I didn't go to school for AI or ML or any of that. I've been completely self-taught in everything that I've done for the past, 20 years or so. But what I will say is now that AI coding agents exist, that ever since I started using Claude Code, I have learned so much more than I thought. So I think that these tools, even though they're writing code for you, the fact that they don't get the code right every single time and requires you as a human to try to understand what it got wrong is always a learning opportunity. So I think if you think about it in that sense, that when the AI gets it wrong, figure out why it got it wrong, you'll always pick up on little elements that you can learn. But in terms of a pipeline for software engineers, that is a good question. I'm not super certain how we're going to keep that going. Thank you.
Okay, is there any more questions? You can type your question in the chat. Maybe one final question before John drop off. Okay, looks like everyone is very clear, super clear with John's presentation.
All right, good to hear. Thank you so much.
Thanks again, John. Looking forward to see you again in the future.
Perfect. I'll be back. Don't worry about it.
Okay, cool. Okay, next we have Chang Sang. Maybe you can share your screen and maybe you can on your camera if you want.
Yeah, sure.
Okay, cool. Nice t-shirt.
Okay.
Okay, so I will do a brief introduction for our next speaker. So for our next speaker, we have Chung Sung Park. He is a senior researcher at the Electronic and Telecommunication Research Institute from South Korea. He'll be giving a talk about web coding, understanding and using it correctly. Okay, the floor is yours.
You start right now.
Yep,
Oh, wait a second.
slideshow. At the top, on the top, yeah, slideshow is.
How can I start?
Yeah.
Okay, hello everybody. I hope you can listen to my voice.
Yep.
I'm Jason Park and I'm from South Korea. And today I want to talk about coding. A lot of hype about coding. So I made it the title kind of spicy, like understanding and using it correctly. So let me go through the slides. So first, let me introduce myself. I love getting. I'm Jason Park, and I'm basically a researcher and open source contributor since 2012. And about AI, I have been loving getting people to see how useful AI is and explaining the technical details. And just a few years ago, when people mentioned about AI, and they didn't trust anything and anybody, and so they say AI can do it. So I always say AI can do amazing things, and giving some of the tutorial sessions, whatever. But nowadays, it seems like everybody trusts AI without question, right? So it can do anything for you. So my attitude has shifted to like we need to be careful about various things when using AI. So anyway, the same purpose, like how we can leverage AI to achieve certain goals clearly and better, whatever. So there's a brief introduction about myself, and today's talk is presentation is largely divided into 4 parts. First, introduction to byte coding, and second, an introduction to some of my experience with byte coding, where I found it incredibly useful. And I want to discuss the impact of benchmark results, which are always released with the release of LLM model and that has something to do with our byte coding experience, I think. And lastly, I'll conclude my presentation by sharing some of my thoughts on byte coding. So let's get started. So what is byte coding? So first, let's look at the result of the survey developers conducted by Jeff Ryan late last year. It's been quite some time, even though it hasn't been a year yet. So while these figures are likely to have changed significantly maybe by now, even a year ago, right? But 79% of like 23,000 respondents said they had used ChatGPT or Copilot to do something about development. So considering the short period of time since ChatGPT's introduction about like 2 or 3 years ago, we can see how quickly it has become integrated into our lives. And so the term vibe coding was introduced by Andre Carpenter, right, earlier this year. However, his brief post is more about description of the behavior of what vibe coding is than a definition itself. So therefore, I will define vibe coding using two words: immersive and enjoyable. But is there any developer who hasn't experienced both immersive and enjoyable experiences, like spending overnight and looking for the AI, looking for the developer documentations, write code, and finally make it work, something like that kind of experience. So in other words, by definition, vibe coding isn't a completely new concept, just in my head. So what's special is that it is integrated into our experience. I mean, the AI is integrated into our experience. So there's a missing word, AI, in form of vibe coding. So the main reason, there are three main reasons for this. The first is the natural language interface. Simply write down your intentions in human language, and they magically translate into code bases, code snippets, whatever. So this magical translation capability is one of the major thing. And the second is the rapid generation speed. It's possible to generate massive amounts of code in seconds. So this is because with sufficient computational resources, machines can generate code simply by performing calculations. But lastly, it breaks down the barriers to entry between domains. While it doesn't eliminate domain expertise, in my opinion, which requires deep understanding, it does break down the technical expertise required to code, such as web page design or implementation. I mean, if you're majoring in certain very deep dive, some academic lecture or whatever, but you don't have a knowledge of building up a web page or the simulation, whatever, vibe coding can help you with it. So the vibe coding that's being talked about these days can be seen as an act of coding with immersive and enjoyable experience, but using a tool called AI. So that's my own definition of the vibe coding, and if you agree or not. So there are four main tools for the vibe coding currently. So the first one is the playground, which is the most accessible. The screenshot shows the result of rendering code generated in real time into a web page using feature called Canvas, provided by Gemini service. So you can describe your desired output in the chat window, just like in a casual conversation. In web-based application that matches your description will be created instantly, anytime, anywhere. While Playground offers accessibility, it has limitations for professional use. It's not particularly suitable for large-scale projects, in my opinion, and generating new code each time can be inefficient. However, I think Pro subscribers has virtually unlimited access to generate an unlimited number of tokens. So making it an ideal tool for exploring a wide range of ideas early on. I mean, if you start by coding very solid idea with every requirement written down in every single detail, you don't really have to use this such tool, but everybody starts by coding with very little specifications. So a lot of details are filled in with hallucination. So meaning to find out the best resulting to your requirements, you have to explore a lot of different idea spaces. So Playground is very suitable tool for that. The second tool integrates AI with IDE-based code editor, such as Windsurf or Cursor, which we are all familiar with today. So these tools offer significant advantages, including the ability to easily designate code regions and view code changes in real time with readability. Readability is very important, I guess, because AI generates a lot of code, massive amount of code very rapidly, and if you just give up, you don't really have time to look into every single details of the Java code, and just you believe, oh, AI may code just works, but I don't think so. Unless you need to handle multiple projects simultaneously and asynchronously, I highly recommend using this tool alongside playgrounds because of its ease of control. You can control agent mode or fine granular mode, like scroll down and find out the focusing area and ask AI what to fix, what to do more, whatever. So anyway, the third tool is a terminal-based multi-agent code editor, such as Code Pro or Gemini CLI, which has gained rapid popularity since mid-year because they are terminal-based. They require very few resources to run programs, allowing for simultaneous work on multiple projects utilize the web. They are a coin tool with a futuristic vibe, perhaps the reflection of the vibe. This explains the rapid rise in popularity of this. However, terminals often have difficulties checking code changes, making it difficult to conduct meticulous and thorough inspections beyond simply capturing the vibe. These characteristics in particular requires communicating everything about the overall file scope in natural language, making them more challenging than expected and often leading to trial and errors. We all know that it's difficult to align interest through one-on-one conversation even with people, and this explains why terminal-based code editors are so challenging sometimes. I mean, if the project scale grows bigger and bigger. And the fourth tool is this asynchronous agent-based system-style coding assistant. The idea is to simply give you a request, leave and return when the alarm rings, and the desired task will be completed. While this sounds really idealistic and futuristic, it's common to have a 99% trustworthy human assistant. However, if we need to ask ourselves, like, can we truly trust AI with 99% confidence? Personally, I believe AI's reliability is still significantly low. So that's why we just sit down on our desk and watch the monitor, even though we don't really understand what AI is doing. However, from the perspective of predicting future directions, it's worthwhile to be aware of the existence of these tools. So I introduced the four tools. So what are the best tools for vibe kind of coding, vibe-driven development? Actually, there's no single, the best tool in my opinion. But personally, because if you go very serious about vibe coding, you have to put a lot of money into it because you have to switch to much more expensive, model like Cloud Opus or Gemini 2.5 Pro. And in my experience, I used maybe like 10 billion tokens in a week very easily and spent about like $3,000 to $5,000. It's kind of very easy. So that could just happen a lot of time in terminal-based and asynchronous-based vibe coding tool. So it's really hard to control the price yourself. So my choice, my personal best choice is just to explore the playground of life. So exploring the initial idea space and filling in the missing parts, hallucinated missing parts, a lot, and finding out the most ideal, the initial code base, and then move the code base into ID based. I use IDE a lot of time until I understand AI's behavior, how AI is reflecting to my requirements. And then I think if I fully understand AI's behavior, I can go to the terminal based, just relying on AI's, because I know you, do whatever you want to. Something like that kind of, So these days a lot of people just recommend to use quote-unquote terminal-based tools because they are vibing. But my recommendation is just choose the right tools for right situations and move and shifting from one tool to another in appropriate time. So somebody says vibe coding almighty, in my opinion, there are a lot of reasons, but I have very limited time to talk about it. But at least they can be used as a tool to increase your development productivity. The problem is how much productivity can be increased is actually very up to you. Like, in my opinion, we cannot really completely replace our current development behavior with vibe coding. But instead, we have to really think about how we can integrate vibe coding into the existing development method, such as like using IDE-based or something. And in vibe coding era, because we are all relying on large language model, it's kind of questionable how effectively we can convey instructions well and how to make LLMs troubleshoot better, because it consumes everything in a text base. Would it be better to produce, troubleshooting report in text, like Markdown or whatever, a lot of low base or whatever? What would be the best way to troubleshoot? Because troubleshoot is very important for software engineering. Something like, so you have to think about it. I don't really have an answer to this, but it's just based on your development, behavior. So think about it. And how well do you really understand about AI model? Because vibe coding is like an agentic program. And agentic program means it's directed to a lot of different layers. So at the core, there is a single AI model, and there are a lot of shells, on top of each shell, and that makes vibe coding. So how well do you really understand about this? So let me just talk about this, some of the issues. I'll introduce, I actually had a very successful experience using vibe coding to do a project. So let me introduce about that. You don't really have to understand this picture, what it really is, but basically on the right side of the picture, it's just stack up the network components to be controlled. Computer networks, like there's controlling platform, there are a lot of software components. So my purpose was to build AI agent that manages controls the network, so interacting. So, but this is kind of very, very trendy research these days, because every researchers in their own field, they want to bring AI into their own existing systems, right? So adding AI capabilities to existing systems to enhance, some of the intelligence. But the problem arises due to the nature of natural language, right? Numerous variations must be tested to ensure stability. Because in a traditional computer software engineering, we have a certain fixed set of inputs to controls, right, to test out. But natural language is kind of arbitrary. Everybody can express in their own way the same thing. So, same thing, but in a lot of different ways, has to be tested out to ensure the user experience, right? And for the AI integrated in a system. So that's what I wanted to do. But applying directly AI agent to test these kind of variations to existing systems is very risky. So I just want to build a simulation that mimics the right-hand side of the software components. So my goal was very clear: simulation, but just to focus on the controllability of the natural language systems. So detailed operating principles do not need to be the same as the actual system. Just in the perspective of input and output, it has to be clearly set. And I know because I have been working in this area for several years now. In my hand, there are a lot of details into this. So I can just simply write down a few hundred pages of specifications. So the second thing is transferability from verifying agent workflow to real world network without conflict. So HTML workflow in a lot of variations of natural language and a test bed like a simulation and transfer the successful case back to the real world network device. So my purpose is to vibe coding this simulation. Because I said, like, I know every single details of the, how network components work in a function level. What comes in, what comes out. I don't really care about the detailed inside. I mean, when I design this kind of simulation, right, it doesn't really have to follow the exact protocol, like HTTP or gRPC, whatever. It just has to convey the right message to the right destination and do some changes in the right direction. So that can be achieved with a component level development methodology. And this kind of project can grow very larger and larger. And so vibe coding cannot really handle this kind of very large code bases, but I can isolate one problem at a time. Of course, referencing some of the code bases, but I can isolate the problems because I know every single details, right? So list of CLIs, their definitions of input and output specifications. Of course, there are internal components when some of the CLI commands are launched. And define the state transition according to the execution of each CLI. So as a result, fully implement all function input and output as per the specs were not involved in it, even though I was not totally involved into the implementation. I just wrote down every single detail in natural language, and everything booms. The simulation just created not a single shot, but a lot of shots. But the important thing is I could implement such thing because and eventually I implemented simulation environment to validate system control stability using natural language, and I actually transferred these results back to the real world test bed. So I wrote a paper about it, and it got accepted at a certain well-known conference for network researchers. It's kind of interesting to see it as this kind of successful story for me because this is kind of significant in my opinion, because more and more existing systems will be controlled by AI, right? In my opinion, that's correct. But it is difficult to verify the possibility of stable AI controlling real environments because of the natural language, nature of the natural language. However, the maturity of the existing system is very high, right? Everything works almost like a 99% correctly without failure. And the functional specifications are very clearly designed and documented. I mean, if you are an expert in a certain area, you know almost everything about it. Right? And if you look in the documents, you understand probably everything. This allows for vibe coding of realistic simulation environments. Kind of vibe coding in such kind of situation is very likely to be successful in my opinion. So I just wanted to share about this kind of experience because I think a lot of you have your own expertise. So you can just think about what this project really means in the vibe coding area. Now let's move to the benchmark real world gaps. All of a sudden, this is kind of one of the most important topics to understand vibe coding. So the first question is like, how well do you really understand benchmark scores? I mean, if you follow up with some of the news that tech companies releases their own LLMs, you usually polyglot or software bench verify. And if you look into it closely, they annotated like a code generation capability, code editing capability, agent code capability. So, believe it or not, and I don't really know what you think about benchmark scores, but at least this tech giant think these benchmarks are important figures. And they are smart people. So we have to actually understand why they think it is important to understand such benchmark scores. Even though this benchmark score doesn't really reflect your own experience. Actually, if you have your own way to create your own benchmark data set or an own method reflecting your own business use cases, use it. That's the best way. But it's very difficult to create a benchmark, unbiased benchmark, covering all use cases of your business model. It's very hard to build up such benchmark. So it's not an easy work, but if you have it, the benchmark yourself, just use it. That's the best way to reflect. Otherwise, we have no choice but to trust the reported benchmark scores first. So you need to check how well you really understand the benchmark scores. For example, if you see high scores in software engineering benchmark, does it really mean it's overall good at software development, even though it has an annotation like agent coding capability? Is not actually. And of course, another benchmarks like human eval and MBPP, if you see high scores on those, does it really mean the model is overall good at repository level problem solving? Not really. And if you see the high scores on MRCR needle haystack, does it really mean LLM has a good capability understanding 1 million context as they advertise? We have 1 million contents, 2 million contents. The reality is it is not. And a lot of benchmarks they are, and you have to expect it. Because every single benchmark comes from very rigorous study and paper in a very high respectful, academic conference. Meaning this is not a useless benchmark, but it's very useful. So you cannot really believe the scores on this benchmark with a single sentence. You have to go through the full paper and understand what it really means. That's my opinion. But there are some hidden pitfalls in benchmark score. First, target language. If you don't understand what these benchmarks are, don't worry about it. It doesn't really matter. But in recent years, maybe in the last 5 or 6 years or so, numerous benchmark data sets for evaluating coding skill have emerged. The problem is, most of them target Python. The yellow color benchmarks are all targeting Python only. And there are some benchmarks targeting Java, but as you know, Java has a very complex structure. So it's very hard to design benchmark for Java coding capability. So there's very limited benchmark, even though some benchmarks says we have benchmark for Java, it doesn't really reflect the real world use cases. So keep in mind, many of the agent coding capabilities are tested in Python-based benchmark data. So let's briefly understand about the software engineering benchmark. It's just basically scrapping the successful pull request from popular Python repositories, and which is coupled with issues and passing all unit tests. Okay, to truly understanding what benchmark data set is, you have to understand how it is collected and what is the statistics of the benchmark data set. And by using this benchmark, how does it verify models' coding capability? So it scraps the data like this, and as a result, they collected the numerous data set. But surprisingly, they collect all the data set from popular Python repositories. So it's just a Python level software engineering benchmark, not software engineering in general. And if you look into some of the popular repositories scrapped by this project, was basically some of the web server application, Django, Flask, and much of the others are about data science specific packages. You know, but in real world there are a lot of different tasks done in Python. So that kind of tasks are not verified by this benchmark. So with this benchmark data set, LLM is asked to solve an issue and has to hold out, check set. And if LLM generates solution code, patch code, and that solution code passes all in the test, is marked as a verified. So it's basically how well large language model solves a problem based on issues and the unit test. Okay? So if you think this kind of table is awesome, like 63.8%, it has been improved a lot. Okay, it's probably the right time for going, quoting myself by looking at this software engineering bench. And if you reflect such benchmark score into the real world experience, you have to understand how these data sets are constructed, the prompt essentially. So basically, the software engineering benchmarks grasp the successful issue, meaning very well written issue, right? So you have to follow basically the ideal issue writing practice, like a writing title, writing body, like issue description, what kind of environment you tested out to reach this issue, what is the reproducibility method, how you can reproduce such error issues in your own environment, and what was the error message, and what would be the expected result, something like that. So basically for reflecting the scores of software engineering benchmark into real world use case, is you have to structure the prompt with the same practice that you write ideal issue. So another example is the problem solving, like Bench or Haters Polyglot. Basically, it's just they are following up, coding interview style of the descriptions, like explaining some of the situations, what is the specifications, they put output, additional context. But the thing is, they are well written, okay? It almost has every single details what this solution has to do. So if you want to build, if you want to use LLM to generate solution code snippet, for your use case, be specific, be detailed as much as possible. I mean, nowadays, the scores on these benchmarks are going very higher and higher. And this is a good thing because if you follow the best practice prompt, writing best practice just like this, you can get very good experience. Another pitfall of the benchmark scores is like long contextual understanding. Like every single models in these days, they advertise their models. We have 1 million context tokens. We have 2 million tokens window. And it's a very large context window, in my opinion, because if you look into some of the popular repositories, one of the largest repositories, there are like a few million And there's no chance you pass all the repository levels of code into this model directly. And I'm pretty much sure your own project doesn't really have this much of the code. So meaning, almost you can pass entire of your project into the model. So it doesn't really mean it understand my repository 100% correctly, because the companies advertise we have 1 million context understanding. It really is not. So you have to really look into benchmark, because they advertise this long context length by showing the benchmark scores. Okay, so one of the popular benchmark score is the fictionalized bench. It's a private data set based on the real user data. So there's one single answer input surrounded by the chunk of text. And it begins with a very small chunk of text, and it adds more and more data synthetically generated, more and more up to 120K tokens. And if model can find out that single, that single answer correctly from this a large chunk of text, this benchmark marks the LLM correctly classified. But so if you look into it, the model, all three model and Gemini 4.5 Pro model does pretty good job. But other than that, a lot of different models that we probably thought the model awesome, but didn't really good job. For example, DeepSeek 33.3% accuracy on just the 128 the context window. But if you think about it, it's just the same finding out one single needle in this a lot of context. 71.9% of accuracy is not really a good performance. Oh, okay, so sorry, my voice is too large, so let me lower it down a bit. So there is another benchmark reflecting these kind of limitations, like this finding out single needle. So MRC benchmark is originally introduced by Google DeepMind, but they didn't really release the dataset itself. So OpenAI developed the dataset based on the method that Google DeepMind introduced. They released it open source. It's basically just asking LLMs to write down the portrait, blogging, whatever. But at the end of every single turn of writing, it generates hash value to find it out, and after producing a lot of context. So here is benchmark scores. This is a pretty good result, but it's basically adding 2 needles in the context. And this performance significantly drops when there are more and more needles to find. Okay? So, but by reflecting these benchmark scores into a vibe coding experience, vibe coding doesn't really happen isolated manner. To write down a single Python function or whatever algorithms, LLM actually has to go through a lot of different parts of the repository, and even even some of the developer documentations, and every information has to be combined. So finding out, it has to find out, I think, more than 8 needles, right? So the limitations of writing code and finding out the needles in the long context is really issue for vibe coding. So don't really believe vibe coding is almighty, but understand the limitation and capability of the models, and by reflecting that capability of the model into your experience. So this is one value, because I rely solely on benchmark. I was implementing some of the multi-agent system based on agent development kit introduced by Google on April 22nd. Very recent framework because I wrote down these slides like for May. So the quick start guide is pretty good. You can follow up the quick start and develop a simple use case. But there's no advanced use case well documented. And so I don't understand how to use it for very advanced architecture. And I found out LLM doesn't really understand it too. So it is not really enough to just provide references to LLMs that have not trained on. So there's not reflection. LLM does not really know best practices. Of course, no best practice, just spits out word by word for best practice. If best practice is not readily well documented in particular, and if it uses slightly outside the basics. As we see, it has a long context problem because to understand the newly released some of the toolkit, you have to put every document and probably the entire repository to the LLMs to generate code bases. And long context problem happens. So I joked that it couldn't figure out the relationship between needles. So if you are in kind of similar situation, just think about my experience that I shared this. So the lastly, it is about rethinking by coding also. So I showed the adoption rate of AI for developers is rising very quickly in the first slide, right? But this is another survey by NetLippy, State of the Web Development Report. It's not just about the experience of using ChatGPT, but actually using an AI tool to develop production level web page or web service. It was happening in the kind of very similar time, and a lot of its participants. And last year, almost the majority of people didn't use AI for production level, website building. Even though a lot of people has experience using ChatGPT and Copilot, they neglect to use it for kind of serious use cases. Maybe due to some of the issues with the generated code quality, accountability, whatever. But actually, this was the statistics I can show. And this was a report by Clear, AI Copilot code quality this year. And they examined the data from the very popular code bases, about 211 millions of lines of code through 4 years. The problem is the proportion of the copy and paste identical code keeps increasing. And the proportion of the existing code being refactored. So meaning, if there's a commit history, moving one code snippet, multiple similar code snippets into one single code snippet, that means refactoring. They said proportion of the existing code being refactored is decreasing more and more, meaning probably in the next few years we are going to feed garbage data in and out to the model itself. That's kind of an issue because even though model capability is going to increase better, it means it can solve a problem, but it doesn't really mean it can generate beautiful code, right? For example, a problem can solve like 10 lines of code. AI generates probably 1,000 lines of code is not really manageable. I mean, in real-world software engineering perspective. So you really have to define what byte coding is. The definition allows you to clearly select the tool you want to use. So what type of immersion do you really want? Some people say, let's free ourselves by entrusting our bodies and minds to AI tools, just relaxing, lying down, writing prompts, ask AI to, develop AI tools or software. I'm going to have some fun. Yeah, this is not a bad perspective, in my opinion, but it depends how serious you are, how serious project you are participating. And probably you want some kind of immersive experience, like carefully read responses or write prompt to set the directions correctly. Of course, you have to use a lot of energy to manage this kind of usage. And what do you really want to achieve as a result of immersion? High quality code, and probably high quality code, but you don't really have to write high quality all the time. Low quality or working result, like the proof of concept possible quickly. I don't really mean, this perspective is bad, this perspective is good. This perspective is bad, this perspective is better. It's just based on your own use cases. But think about it. When to use bytecode and how to use bytecode. So, and we really need to change our existing thinking somewhat. And AI is total collection of all means of artificial intelligence. AI is actually a multi-layered packaged product. Because AI, when we say AI, we don't really say AI model. AI is a very high level conceptual something, right? To describe some kind of magical stuff. So it begins with language modeling, of course. Deeper inside, it begins with that propagation, but language modeling first, pre-training. Because in every single stage, it has to do something about data set and how it is wrapped into. So language model, what kind of data set we have used to pre-train such model. Reinforcement learning, unlocking the problem solving capability. What kind of data set we have used to increase the problem solving capability. And supervised fine tuning. How we make the model to follow up human instructions effectively. And it's kind of very hidden part. Every vibe coding tool has a RAG integration. They will say RAG is integrated. So how they really consume external knowledge is kind of very hidden piece. What kind of data set is used to train the model, how they consume this external knowledge to augment the generation. And of course, agent workflow, agent system workflow can be made by some of the very high level frameworks such as LangChain, LangGraph, or Creo, or whatever. An agent system is a collection of such workflow. Because natural language interface itself is a very high level concept, right? All of these details are wrapped into, packed into, a single word, AI. Very, very conceptual at high level. So do you really understand what AI is? I mean, when things don't work as expected, how are you going to deep dive into the problem? So you really have to understand. So by understanding these kind of issues and this kind of wrapping hierarchy, you can switch model from model to different model and just to some kind of fix some problems. Probably you cannot really fix the pre-trained stage, but you can fix from reinforcement learning by yourself. And this is an additional tip, the last one. When I design something with the microphone, I usually use these tools, this kind of tool. So I ask AI to generate web page design, but I don't really have all the specifications. So I want to explore with the main core idea working. So I just want to generate multiple choices at once. So in this case, I use the strongest model to explore the initial idea space, probably up to 10 or hundreds of ideas. And if I select one single result out of 100 that gets to my requirements very well optimally, then I can go beyond based on that selection. Because I grounded that selection and started to evolve from there, right? From now, I can use less capable model, for example, Gemini to convert Flash, because it doesn't really have to handle all the very delicate code generations work. So it's one of the tips. This is an example to find out some beautiful designs of the simulations for the Gemini Pro. And you can use a lot of thinking budget for initial iteration, but later on you can use smaller model for the less thinking budget. So this is all my talk. Thank you for listening.
Okay, thank you, Chang Song. You guys have any questions to ask? I think there's one in the chat. Can a wipe coder really orchestrate specialized AI agent? For example, a developer, a QA, and a security engineer into a virtual team under human project manager or product owner oversight? Or do we see as the real limits today?
Oh, wait a second. Sorry. So, my recommendation is do not use vibe coding for building up AI agent. Because AI agent basically relies on prompt development. And if you have multiple agents, prompt chaining happens. And there are a lot of prompt choices, a lot of combinations. So I don't really recommend exploring such large spaces. Instead, building an agent is very easy relative to traditional software engineering. So I recommend just the vanilla Python, test out the POC level of AI agent system first, then move on to the popular frameworks such as LangGraph or production use cases. Sorry.
Okay, I think that answers your questions. Do you have any other questions? As for the rest, the slides today the session is recorded for both both talk session. I will upload into YouTube and share the link. I think Chang Song will share the slide with me, and I will ask the slide from John later. I will also share the slides. Any last comment from your side, Chang Song, before we end the session?
coding, I said, vibe coding is harmful to use it. Sorry about that.
No, okay, good.
But
The slides and the video will be shared in our Facebook page, the Artificial Intelligence and Machine Learning, and also in the LinkedIn page. I will share there. Okay? Okay, I think it's also getting late for you, Jiangsong. It's already coming to midnight for you. I think thank you everyone for attending today's session. Very thank you for Jiangsong and John for the talks today. We're looking forward for our next meetup in coming months. Yeah, thanks everyone. The recording will be shared, the slide will be shared in our Facebook page and the LinkedIn page. Thanks everyone. Thanks, Jiangsong. Have a fun time at Bali.
no.
Bye everyone.